Okay, now next is left factoring. This is again a very important point, left factoring. This is like we know there are two types of grammar, right? So in very shortly, I'm going to say, give you these details. So if there are two grammars, if there is a grammar, then this grammar has two parts, right? One is deterministic grammar and non-deterministic grammar. Right. So in order to convert a non-deterministic grammar into a deterministic grammar, we need to go for a left factoring. So means what? What exactly non-deterministic grammar? If our input string is, say, for example, input string is, say, alpha beta 3. Okay, so we can produce this alpha beta 3 like from A. So here, say, from A, if I wanted to produce alpha beta 3, so means I can go with the first option, say I can produce alpha beta 1. Oh no, it is not. Then I can go with alpha beta 2. Then no, I can go with alpha beta 3. So once it comes to the third place, I'm going to take. So means what? The decision comes later. So in order to improve this representation, what we need to understand, if this is the representation of the grammar we have, which contains some common term and some non-common terms. Common terms means what? Now look at the production. A implies alpha beta 1, A implies alpha beta 2, A implies alpha beta 3. So what is common here in all the production? This alpha. What is uncommon? That is what is different, that is B3. So the decision is based on B1, B2, B3. So whenever the replacement is going to come, then the later decision is going to follow. So this is going to be a non-deterministic representation. When exactly deterministic representation comes, like A implies alpha Z. So what we have done is we have taken this common term out and represented beta 1, beta 2, beta 3 as a Z. So means what? A implying alpha Z. Then what is Z? Z comes like, okay, Z comes either I can go with beta 1, I can go with beta 2, I can go with beta 3. Okay, so which means that if my input string is alpha beta 3, then I'll produce alpha and substitute Z by B3. So means what? Here alpha beta 3. I can directly generate, but this is not. So I need to produce this, then again I need to backtrack. Okay, no. Then again I need to backtrack. Then alpha beta 3, oh, then I can represent it. Okay, so means what? This is, you need to go for backtracking here. You require backtracking here. So decision becomes non-deterministic. And if you replace this as this grammar representation as, if it is A implies alpha beta 1 or alpha beta 2 or alpha beta 3 dash 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 n. So this entire representation you are going to convert as A implies alpha Z, Z implies beta 1, beta 2, beta 3, so on so. Okay, so left factorings are suitable for particularly for top-down parsing itself. So there are two most important issues that are going to come here is left recursion and left factoring. So left recursion is again important point, and left factoring is important point. So in case of left factoring, what we will be doing, we will be looking at the grammar representations, and we try to identify the common terms out of it, all representation, subsequent representation. Then we will be combining all those subsequent representation, and we will be simplifying the grammar so that we can make that grammar more deterministic.